Hi everyone. Welcome to today's lesson, where we'll explore one of the foundational topics in chemistry, the three states of matter. By the end of this video, you'll have a clear understanding of what solids, liquids, and gases are, how they behave, and why they behave the way they do. Let's dive right in. What is matter? To start, let's define matter. Matter is everything around us that has mass and takes up space. It includes all the substances and materials that make up the physical universe. From the air we breathe to the water we drink and the ground we walk on, everything is made of matter. There are millions of different substances, but they all can be categorized into three main states: solids, liquids, and gases. These are known as the three states of matter. Solids. Let's begin with solids. A solid, at a given temperature, has a definite volume and shape. This means that solids hold their shape and don't flow like liquids or gases. For example, think about an ice cube or a rock. They keep their shape unless you forcefully change it. Why do solids have a fixed shape and volume? The particles in a solid are packed tightly together in a regular pattern. These particles don't move around freely, but only vibrate in place. This tight arrangement and limited movement are why solids are hard and maintain their shape. Effects of temperature. When you heat a solid, its particles vibrate more vigorously and push each other slightly apart, causing the solid to expand. This process is called expansion. Conversely, when you cool a solid, its particles vibrate less and come closer together, causing the solid to contract. This is called contraction. Examples of solids. Common examples of solids include ice, metal, wood, and plastic. Each of these materials keeps its shape unless acted upon by an external force. Liquids. Now let's talk about liquids. A liquid, at a given temperature, has a fixed volume but no fixed shape. This means that while the amount of liquid remains the same, it can change shape depending on its container. For instance, water poured into a glass takes the shape of the glass. Why do liquids flow and take the shape of their container? The particles in a liquid are close together but not in a fixed pattern. They have more freedom to move around and slide past each other, which is why liquids can flow. These particles are still held together by attractive forces, but these forces are weaker than those in solids. Effects of temperature. Just like solids, the volume of liquids changes slightly with temperature. When you heat a liquid, its particles move faster and spread out a bit, causing the liquid to expand. When you cool a liquid, its particles slow down and come closer together, causing the liquid to contract. Examples of liquids. Common examples of liquids include water, oil, and juice. These gases. Lastly, let's explore gases. A gas at a given temperature has neither a definite shape nor a definite volume. Gases will expand to fill the entire volume of whatever container they are in. For instance, if you blow air into a balloon, the air will expand to fill the balloon. Why do gases fill the entire space of their container? The particles in a gas are far apart and move around very quickly in all directions. They collide with each other and with the walls of their container, but these collisions are less frequent than in liquids. The particles in a gas have a lot of energy and move freely, which is why gases can expand to fill any space. Effects of temperature. Gases are highly affected by temperature. When you heat a gas, its particles move even faster and spread out more, causing the gas to expand. When you cool a gas, its particles slow down and come closer together, causing the gas to contract. Gases are also highly compressible, meaning you can squeeze them into a smaller space due to the large amount of empty space between the particles. Examples of gases. Common examples of gases include air, oxygen, and carbon dioxide. These gases fill their containers and can easily be compressed. The kinetic particle theory. To understand why solids, liquids, and gases behave the way they do, we use the kinetic particle theory. This theory explains that all matter is made up of tiny particles that are always moving. The way these particles move and interact with each other explains the properties of solids, liquids, and gases. Key points of the kinetic particle theory. All matter is made up of tiny, moving particles, invisible to the naked eye. Different substances have different types of particles, such as atoms, molecules, or ions of varying sizes. The particles are always moving. The higher the temperature, the faster they move. Heavier particles move more slowly than lighter ones at the same temperature. Explaining the states of matter. In solids, particles are held closely together by strong forces and can only vibrate in place. This is why solids have a fixed shape and volume. In liquids, particles are close but can move around each other, allowing liquids to flow and take the shape of their container. The forces holding the particles together are weaker than in solids. In gases, particles are far apart and move freely and quickly, filling any available space. The forces of attraction between the particles are very weak. Examples and visuals. To help visualize these concepts, let's look at some common examples and how they fit into the kinetic particle theory. Solids. Think of ice cubes. Ice has a fixed shape and volume because the water particles are tightly packed together in a regular pattern, only vibrating in place. When heated, the ice melts into liquid water as the particles gain energy and move more freely. Liquids. Consider water in a glass. Water takes the shape of the glass because the particles can move around each other. When cooled, the water can freeze into ice, and when heated, it can evaporate into steam, a gas. Gases. Imagine blowing up a balloon. The air inside the balloon spreads out to fill the entire balloon. The particles are moving quickly and freely, filling all the available space. If you release the air, it quickly spreads out into the room. When a metal, such as copper, is heated, it expands. Explain what happens to the metal particles as the solid metal expands. The particles in copper are vibrating about a fixed point. As the temperature increases, they gain kinetic energy and vibrate more, colliding with neighboring particles. This has the effect of increasing the overall volume of the metal. In other words, it expands the flow. That's our detailed look at the three states of matter: solids, liquids, and gases. By understanding the kinetic particle theory, we can explain why these states of matter behave the way they do. If you enjoyed this lesson and want to learn more about chemistry, please like, subscribe, and hit the notification bell so you don't miss any future videos. Thanks for watching, and see you next time.